De-rustle and de-wind both address issues that might typically crop up in post-production applications. De-rustle is designed to eliminate the noise of a lavalier mic rubbing against the wearer's clothing, and de-wind is meant to eliminate the sound of wind noise, like a mic might pick up outdoors, as in electronic news gathering situations. De-rustle is specifically targeted to a particular issue, rustling noise from a lavalier mic brushing up against the wearer's clothing. Its algorithm is tuned to detect and address this specific type of noise, so it's pretty simple. Reduction strength sets the targeted amount of attenuation for the rustling sounds, and ambience preservation lets the user adjust how much of the general background noise floor will also be removed when using de-rustle. At maximum, other background sound like room tone should be preserved. As you lower it, that will also be reduced. At 0, the noise floor will be removed along with the rustling sounds. There's also a menu labeled Separation Algorithm, which appears in several other modules as well. This provides options for processing quality, which you can experiment with if you feel you're not getting the results you want with the default setting. Independent is the fastest. Joint Channel provides better quality, and Advanced Joint Channel is the highest quality option. Most of the time, Joint Channel, the default option, seems to get the job done. Let's do a quick test on this recording made with a lavalier mic. Here's a recording with a lavalier mic attached to a user's clothing, which is picking up some rustling noises from the clothing while the user speaks. Let's see if de-rustle can remove or reduce that rustling noise. I'll try de-rustle first at the default settings. Here's a recording with a lavalier mic attached to a user's clothing, which is picking up some rustling noises from the clothing while the user speaks. Let's see if de-rustle can remove or reduce that rustling noise. It's slightly reduced the level of the rustling sound, but not enough, so I'll increase the reduction strength. Here's a recording with a lavalier mic attached to a user's clothing, which is picking up some rustling noises from the clothing while the user speaks. Let's see if de-rustle can remove or reduce that rustling noise. That's better. There's still a little rustling noise remaining, but for most practical purposes, the recording is now cleaned up sufficiently. De-wind looks to do the same thing for wind noise picked up in an outdoor recording. Wind noise is usually a low-frequency rumble picked up when the wind shakes the mic's diaphragm. Obviously, the use of windscreens and other physical protections can forestall this, but when you do end up with a recording that suffers from wind, removing it can be a pain. A simple low-cut filter may cut out too much of the main signal, thinning out voices unacceptably, and selecting and removing it by hand with a tool like spectral repair could be tedious. De-wind's targeted algorithm should make it a lot faster and simpler to address the problem, removing or at least reducing bad wind noise to acceptable background levels. Here's a recording that suffers from pretty bad wind noise. Here's a recording made outdoors. There's a pretty strong wind blowing. Let's see how the de-wind module handles this. Let's try de-wind first with the default settings for all parameters. Here's a recording made outdoors. There's a pretty strong wind blowing. Let's see how the de-wind module handles this. Okay, it reduced the wind slightly, but since the wind in this recording is pretty bad, it'll probably need a more aggressive approach. The reduction slider, naturally, determines how aggressive the algorithm will be in reducing the level of the wind. Higher settings will push it down more, but risk affecting the tone of the voice more as well. Here's a recording made outdoors. There's a pretty strong wind blowing. Let's see how the de-wind module handles this. That's better, but the wind is still a little too present for my taste, and I can hear a little artifact on the voice. The crossover frequency sets the point below which de-wind operates. A lot of wind noises primarily rumble, and when that's the case, lowering the crossover should be able to address it with the least effect on the vocal tone. But in this recording, the wind has a fair bit of mid-range energy as well, so I'm going to raise the crossover to try to get rid of that too. I'd expect that this might impact the vocal tone even more, possibly thinning it out further, so I'll turn to de-wind's fundamental recovery feature. This is intended to help restore the fullness of the voice. I'll crank it. Is a recording made outdoors? There's a pretty strong wind blowing. Let's see how the de-wind module handles this. That's better, though I still perceive a little artifact on the vocal, so I'll increase artifact smoothing in hopes of minimizing that. Is a recording made outdoors? There's a pretty strong wind blowing. Let's see how the de-wind module handles this. Is a recording made outdoors? There's a pretty strong wind blowing. Let's see how the de-wind module handles this. And that helped. Though the wind isn't totally eliminated, this recording was pretty much of a torture test. It's been reduced to a significant degree, and the voice still sounds acceptably full and artifact-free. Next up, modules that address unwanted steady background sound and noise in recordings.